All right, not too hard, right? Something that you guys have been exposed to, you're familiar with it. If this is what you wrote, you're wrong. And if this is what you answered on a final, you'd miss full credit on that question. Okay? So here is where the kind of the new stuff comes into play. Okay? What if I had said x was negative 5? What is negative 5 squared? 25. So what is the square root of 25? 5, but what did I say x was? Negative 5. So is this true? No. So what about this? Would that be true? If x is negative 5 and we square it, get 25. Square root 25 we get, do we get positive or negative? Negative 5? No, so that's not it either. Is there some way that, again, these conditions have to be met? We have to be able to have the value inside non-negative, which is true, because when we took negative 5 and squared it, we got our positive value. So that condition was met. But what about this? The simplified value can never be negative. So we know that this is how it simplifies, but what would guarantee that this answer is never negative? Yeah. So here is the additional element that you need to take into consideration. Okay? In order to maintain that second rule of the square root or any even index root can never yield a negative value, you have to be able to incorporate absolute values. So this is your correct answer. Hey, let me talk about the 4 rules of simplifying a radical really quickly. And then we'll move on and discuss some other examples of this when absolute values are necessary and not. Okay, so the first thing is the index of a radical has to always be greater than the powers inside. Okay, this is the one rule. This is the rule that we're going to look at today. So here, an index of 2, a power of 2 means we have to simplify this radical. So we took out one group of 2, or it comes out to be that x value. Okay, the other rules that we'll talk about later in this section is the fact that the index and power cannot have any common factors. Other than 1. Rule 3, there can be no radical in the denominator of a fraction. And rule 4 is just a kind of another way to state rule 3, and that is no fractions inside radicals. Because if you had a fraction in a radical, you truly would have the radical in the denominator as well. Okay, so those are the 4 rules for simplifying a radical. We're going to just talk about the top rule today. Okay, so here's an example of that. Okay, what happens when I extend this? So now our power is greater than our index. So that first condition is still not met. But when you simplify, the way that you simplify, you're always going to look to remove groups of whatever the index is. So from this power of 3, how many groups of 2 can you remove? You can move one group of 2. So that comes out as x to the first. And when you removed one group of 2, how many x's are going to be left inside that radical? One group of 2 is 2. When you remove 2 from 3, you're left with just the 1. Now notice I wrote my powers of 1 here, but when you guys do this, if it doesn't give you any additional information, so the power of 1 is not going to provide any extra information for you. It's unwritten here. Don't incorporate them. I just used it to show you those steps. Okay, so now anytime you simplify even indexed radicals, you have to go back and test those 2 rules that I wrote on this other slide. The value inside the radical can never be negative. You need to ensure that that's met. And then the simplified value can never be negative. So let's look at this. Okay. If we look at the original form, okay, can x even be a negative number? A negative cubed gives you an overall value that is negative. So can you take the square root of a negative? No. So based on this, you don't even have to test for a case where x is negative because x cannot even be negative. It's impossible. It doesn't fit within the domain of that expression. So there's nothing you need to do to this expression. You don't even need to test it for absolute values because you see here that x can only be a positive value. So a positive times a positive, you don't even need to test it. Right, let's take a look at x to the fourth. Okay, when you simplify this, how many groups of 2 can you remove from this power of 4? So it comes out as x squared. When you remove 2 groups of 2, how many x's will be left inside the radical? None. So we're left right here. Okay, so here's our expression. Now we need to test those 2 rules. Can x be a negative number? If you took a negative to the power of 4, can that ever be negative? Nope, so that works. The square root, so this becomes positive. The square root of positive is equal to a positive. So let's test it. If x was a negative and you squared it, would this answer in the form that it is guarantee a non-negative solution? Any number, positive or negative squared, will always be non-negative. So this is left just as it is. You don't have to do anything to this. Okay, let's keep building on this. All right, what about x to the fifth? So when we simplify this, we now have how many groups of 2? We can remove 2 groups of 2. How many x's are left inside our radical? 1. And so now we need to go back and test. Can x be a negative? A negative to an odd power is always going to be negative, so can we take the square root of a negative number? Not possible. So we don't even need to test this to see if x is a negative. We know that it can't be. And so that again is the form of our answer. And let's take one last look. Okay, what does the square root of x to the sixth simplify to? How many groups of 2 can we remove from 6? 3. How many of those will be, after we remove 2 groups of 3, how many x's will be left inside the radical? None. So here we test it. Can x even be a negative number? A negative taken to an even power is positive, so that works. X can be a negative, so we need to test that scenario. If x is negative and we cube it, is this answer guaranteed to be non-negative? No. So we need to have absolute values around our x. So here's a case where we need to put absolute values. Okay, so just try one final one. X to the 14th. What does that simplify to? How many groups of 2 can you remove? 7. How many x's will be left inside the radical? None. And do you need absolute values on this? Yeah, if you test it, can x be negative? A negative to the even power is non-negative, so that clears. So we need to test it. A negative to the 7th does not guarantee a non-negative, so we do need absolute values. So if you put absolute values, it doesn't matter whether it's inside or outside. I'll probably usually just put it around the variable itself and put the power on the outside, but it can be either one. All right, not too difficult. Okay. The one thing that students tend to do at about this point is, if I gave you time to ask questions, you might say, is there a rule? So if x is an odd power, then you don't have to worry about it. If x is an even power, then you only need absolute values if your simplified power is an odd number. So some students try to create little rules to use when to have absolute values and when not to. I would suggest that you don't try to create rules because they can get confusing. What I would instead do is just do what I'm showing you. Test for negatives in each scenario and see if it fits. Because things are going to get a little more complicated.